Hi, my name is Angie Smith, and our project team is composed of Art Webb, Josh McAdams, and myself. Our project goal is to create information visualizations using data from the Arkansas Department of Environmental Quality to determine if establishment of a hog farm in the Buffalo River area has had any effect on the river. The Buffalo River is located in northwest Arkansas in the Ozark Mountains and was the first U.S. designated national river. Many of you may have floated the Buffalo River before and know firsthand, and as this picture displays, why it's known for its breathtaking bluffs, its natural beauty, and it's a popular canoeing and kayaking destination. Recently, however, the state of the Buffalo River has been in question because of a hog farm that was established in 2013. It's been in the news here recently, at least in the local news. In the last few weeks, there were articles in the Arkansas Times and the Arkansas Democrat-Gazette that this commercial hog farm, which is located within the watershed area of the Buffalo National River, was attempting to renew its 5-year permit. There's been controversy over whether the waste from the farm, which is licensed to house up to 6,500 pigs, poses a pollution risk to the river. The picture here on the left shows a waste holding pond. After designated time periods per regulations, the waste is then spread out onto hay fields as fertilizer around that area, that local area. The nitrogen and phosphorus is great for the fields, not so great for the river. Therefore, there's a concern that the runoff from these fields are polluting the river. For our project, we pulled data sets from the Arkansas Department of Environmental Quality, and those data points were collected from designated water quality stations along the Buffalo River and its tributaries, and included data collected from 1990 to present, to 2018. What we hope to do is create visualizations to evaluate the water quality pre and post farm establishment, comparing data upstream and downstream of the hog farm, and highlight whether the establishment of the hog farm has any impact, negative or positive, on the water quality of the river. To analyze the data and create visualizations for this, initially we had to determine where the farm was located in relations to the river and also in relation to the river's water quality monitoring stations. The star is where the hog farm is located along Big Creek tributary, and we filtered the data to selected designated water quality stations directly upstream and directly downstream of the farm, and are using the results from these stations for our visualizations. After that, we needed to determine which parameters, or if all the parameters were key for the evaluation. So next, Art and Josh will describe some of the concepts we're working on to capture meaningful visualizations and also discuss some of the data set problems we've encountered.
Yeah, thanks for that, Angie. Hey, everyone. Art here. I want to talk a little bit about some of the methods that we employed. So as Angie mentioned, it was important for us to kind of partition the data set to understand which stations were directly up and downstream of the hog farm, and as part of the continuing analysis, evaluate those data points over time. And ultimately, we wanted to figure out whether or not there's any kind of special cause variation pre or post hog farm. So if we move over into the next slide, we'll take a look at some of the challenges that we faced that were numerous, a couple of which were dealing with unknown data quantities, various letters like U and R, et cetera, as well as missing data points. And we also wanted to employ some methods to do some variable encoding to make analysis and visualization a little bit simpler. One of the interesting things that we ran into also is that some of the data around the parameters that we would have liked to have evaluated over the pre and post period were not available. So an example of that is the dissolved oxygen levels. Also, as may happen when you're perusing through a data set, we made plenty of mistakes, including going through and doing a lot of these initial comparisons, only to realize a couple days later that one of the stations that we had segmented out was incorrect. And as with any kind of good design principles, we had plenty of bad visualizations that we put about. So in this case, I wanted to try and evaluate some of the parameters using a parallel coordinates plot. Didn't format the data the way it should have been and came up with this mess. And if we go to the next slide, there were other ideas that seemed to be really good, such as evaluating the different parameters over time with the size of a bubble, and a bubble chart, for example, being the magnitude of the result. I wish I could have shared the video here of this animation as it went along. Unfortunately, Google didn't like it, and that's probably for the best. So we'll move over, and Josh will talk a little bit more about, I think, some of our stretch goals and a couple other challenges that we face.
Thanks, Art. Yeah, this is Josh McAdams here, and so far we've talked a lot about the stations immediately before and immediately after the hog farm to try to answer a very specific question. The question of, is there any noticeable difference in water quality before and after the hog farm? But this question could actually be extended out to see how the water quality changes as tributaries feed into the river, because one hog farm might be affecting it, but other things could be affecting. So as a stretch goal, we're playing with trying to visualize the entire river and all of the stations. And so this is an early sketch of it's an HTML canvas with a drawing on it, and it's an interactive graph that shows each of the tributaries feeding in to the checkpoints, to the Buffalo River. The Buffalo River is that main line down the middle. The tributaries are coming in from the right. And you can see the names of the tributaries, and then each dot is a checkpoint. So there's a checkpoint at each tributary, and then there are checkpoints along the Buffalo River in between the tributary sites. But as you can see, we're looking at 2017 November sulfate data, and a lot of these checkpoints don't have data. So we're having a lot of data sparseness, and we're trying to find out interesting ways to include those in the visualizations. So one of the goals is to hopefully have, besides just that question of is the hog farm polluting, but how does the water quality change over time, and how does it change as new pieces of water feed into the Buffalo River? Some specific challenges we're having with this are that the data is very dirty, and I know this is, most of a data scientist's time is actually spent massaging the data, and I've bolded a few of the checkpoint stations that are kind of mystery stations. You can see there's the Buffalo River 0304, which somebody couldn't decide which station something was tested at, 5.9, 6.1, so just some interesting things. And then the Buffalo River 19, the tributary, it does not exist on the map, but does exist as one of our testing stations, so that could have just been an entry error, or it could be a station that is now not used. Another thing is there are 134 different measurements that are taken possibly at any of these given stations, and so that's part of that data sparseness again, where we don't know exactly at this point what is important, what makes good water, what makes bad water, so we're having to try to find the most important indicators and the most populated indicators so that we can try to get some meaning out of this data. Some other things we're working on, as you saw the graphs that Art showed earlier, we have some higher quality, more beautiful graphs that we're working on, and so these are water quality measures over time. We have a lot more that we're not showing in this because we just want to show that we do have work in progress and it is advancing, but we're really excited about what we have to show you in a month. Thank you. And now we'll open it up to questions.